Yes, the session has been started, live streaming on YouTube. You can start the session, please.
Okay. A very pleasant evening to one and all present here. Thank you for joining us for today's webinar. I welcome you all on behalf of Department of Electronics and Communication Engineering, Savitha Engineering College, who has brought all of us together for the webinar on Innovation in Engineering. Now I would request Ms. J. Jayalakshmi Madam, Associate Professor, EC Department, to give introduction about our college. Please, ma'am.
Thank you, Elizabeth. Good evening, all. Savitha Engineering College, an autonomous institution, is committed to offer nothing less than the best. To all of our students, we make the students job ready to face the competitive world by providing an industry standard curriculum that imparts the 21st century skills required for the learners to be the best, which is the motto of our college. The saying, less is more, perfectly fits us as we train students to reach greater heights in life. Over to Elizabeth, ma'am.
Thank you, ma'am. Now I would request Dr. T. Shripriya Madam, Professor, EC Department, to introduce our resource person. Please, ma'am.
Thank you, Elizabeth. Good evening, one and all. I am very happy to welcome Dr. Sudhir Murthy. He is from Virginia, Washington, D.C. He is the CEO, Chief Executive Officer of NEWhub Corp. NEWhub is a clean tech company that specializes in managing technology and know-how for utilities, consultants, and licensed distributors. He holds a BE in Civil Engineering from RV College of Engineering, Bangalore, MS in Environmental Engineering, and PhD in Civil Engineering, both from Virginia Tech University. He is a professional engineer and licensed wastewater treatment plant operator. He has over 150 peer-reviewed publications and over 20 patents and a Google Scholar H index of 44. He holds various other responsibilities such as Adjunct Senior Research Scientist at Columbia University, Adjunct Professor at University of Queensland, Senior Vice President of the International Water Association. Dr. Sudhir was the Innovations Chief for DC Water until May 2018, and he had led the development and implementation of the authority's innovation and technology adoption strategy. During his 16 years of service at DC Water, Dr. Sudhir created, defined, and translated research and development into product, service, and commercial technologies. In addition, he had led the concept development for over $1 billion in new engineering and construction that included adopting innovative technologies and approaches for wastewater treatment, biological nutrient removal, and biosolids management. Much of the work led by Dr. Sudhir was steered throughout worldwide public open innovation approach that led to collaboration with universities, utilities, and professional organizations. These innovative projects were developed through novel approaches of public-public partnership with other water utilities and through collaboration with non-profit universities. More than 80 MS and PhD students from universities in North America, Europe, Australia, and Africa were insourced to innovate at DC Water in a multifunctional and interdisciplinary setting. This approach is now viewed as a disruptive model for collaborative engagement by universities and utilities. Similarly, Dr. Sudhir developed commercial solutions with private enterprise through the development of public-private open innovation approach between the water technology demand and supply sectors, and through the co-development of technologies and financial innovations. The digestive word, Devon, AVN, Indens, AAA, and PDNA technologies for circular economy within advanced wastewater treatment to promote process intensification, energy positive treatment, and nutrient recycling as a part of the commercial suite that he has led for transforming water infrastructure. He has recently led the development of new green climate financial instruments, including the Resilience Bond and Restoration Bond, to promote holistic approaches for infrastructure investments and debt repayments. Dr. Sudhir led teams to win 4 research grant prizes from the American Academy of Environmental Engineers and Scientists, AAES, for new technologies developed in the wastewater treatment. Dr. Sudhir have won various awards. A few to be mentioned are the Academy's Edward J. Cleary Award for outstanding service to this profession, several Water Environment Federation awards, including the Ralph Furman Medal for Academia Practitioner Collaboration, George Gasconi Medal for Wastewater Treatment Operational Improvement, Camp Applied Research Award. We are very much privileged to welcome you to this webinar on behalf of Savitha Engineering College. The session is over to you, Dr. Sudhir. Sir, please.
Thank you.
Yes. Now you can share your screen, sir. I have stopped mine.
You see my screen?
Yeah.
All right. So thank you. Thank you from Savitha Engineering and the academics there for inviting me to make this presentation. I recognize that there are engineers from all fields. So what I've done is really try to bring together a few slides that describe innovation from a general perspective, a little bit about the history of innovation and the importance of innovation in the past 1,000 years or so, but certainly where things are headed in the future and what are the tools that are important to be innovative in the future. India as a country is emerging into a powerhouse of engineering, and so what are those best tools in innovation that can make it at the top of the charts in terms of producing new products and new technologies and new services. So what I will do is give this presentation from a perspective not of any details associated with any branch of engineering, but really how engineering interacts with society, and engineering is really a part of a larger whole within the context of producing new things. I will basically talk about innovation in general, and especially the dispersion of innovation, how innovation can spread. It's not very unlike COVID-19. It's an infection, and how do you infect people with new ideas and new concepts? Intangible assets are a really key aspect of creating products and services. I'll talk a little bit about that and the notion of what needs to happen to produce intangible assets, regardless of the field of engineering. I'll touch upon the scales of innovation, and it really is all about obsolescence rates as well as gestation periods of different technologies, horizontal versus vertical innovation, engineering platforms, and partnering. I wanted to start with history. This is a nice book that was written quite recently, Why Nations Fail. And this book really describes a little bit about the Industrial Revolution. And And you can see the graph at the bottom. It starts from 1 AD and it goes on till almost today, probably close to 2000. So imagine the graph today, and you can see from the first maybe 1700 years, the increase in world GDP wasn't that much, maybe a factor of 10. And from 1700 AD, that is the dawn of the Industrial Revolution, till today, the increase in world GDP was a factor of 10,000. So a lot of the increase in world GDP has occurred since the Industrial Revolution of 17 that started around 1700 AD, and 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 we call it Industrial Revolution, but I think we depersonalize. It's really an engineer's revolution. Engineers were the most important creators and innovators in this revolution, and so it's really a lot of this increase in world GDP, 10,000, a factor of 10,000, was because of engineers. And a key factor in this this huge change, factor of 10 to factor of 10,000, was the Statute of Monopolies that was passed in the United Kingdom in 1624 AD, which was really the harbinger of the patent laws. And once the patent laws and the were enacted, and the legal system were able to uphold those patents, there was an incentive scheme that allowed engineers to invent and innovate and enrich themselves, but really also increase world GDP. So the invention of the car made the inventor rich, but it also increased world GDP by facilitating transport. The invention of the dishwasher did the same, and so on. Invention of water treatment systems, wastewater treatment systems, they all increase world GDP. And so the Statute of Monopolies and the patent laws were really crucial for this change. And so it's a concept that one needs to appreciate in the context of how it transpired over time, and really this 10,000-fold improvement in world GDP. So in some ways, I think of diffusion of innovation as, and many of you know what diffusion is from a physics perspective. Fick's law of diffusion is a slow process. What we need is a dispersion of innovation, which is a much fast process where you disperse technologies using energy, and in this case, it's using some incentive drivers. This next graph is also interesting. It's the same graph that I showed on the bottom left in the previous figure, but this is more from a geographical perspective. The same 180, and you can see that since probably maybe even from 500 BC onwards, the center of gravity of world GDP was somewhere between India and China, and mainly because of population centered between India and China, with a slight pull from Europe. And so you could see it was right. You can see in somewhere in modern day Afghanistan was what was believed to be the world's economic center of gravity. This is from McKinsey. And around 1000 AD, it was in the same location. 1500 AD, it was about the same. And with the introduction of patent laws around in the 1600s, it started to move. And a huge increase in world GDP resulted. And of course, it ended up in the 1950s between Europe and the United States. And then something strange happened. It started turning, and this was really early on with the dawn of China as an economic powerhouse, but soon thereafter the dawn of India as the new economic powerhouse, and you can see in over time that that economic center of gravity has headed back to Asia, and who knows, in another 20 years it'll be back where it came from. So so you can appreciate how important engineers and engineering is, and the engineering revolution rather than the industrial revolution that is it was important in the past, but is even more important in the future. And the role of India is going to be huge in the next 20 to 30 years. India is going to become an economic powerhouse. It's almost ordained because of many reasons. Demography, especially the dependency ratio, especially in states like Tamil Nadu, is fairly low. Dependency ratio means in the numerator how many people are working, how many people are dependent, and in the denominator is how many people are working. And in states like Tamil Nadu, the dependency ratio is really low, meaning there are a lot of people working for the number of people dependent on you. When you have lots of children, your dependency ratio is high, and so so your numerator is high. When you have lots of old people, your dependency ratio is high. So in Europe, the dependency ratio is very high from a lot of old people and a lot of retired people. Same in Japan. But for example, in North India and in Africa, the dependency ratio is also high because of a lot of young people. But then there is this Goldilocks period, this sweet spot when the dependency ratio goes down, and that's where Tamil Nadu is, and that's where a lot of South India and parts of India are, where you grow really fast, and that's where India is right now, especially the southern part, and so it's ordained. India is going to grow fast, and it's going to grow fast because of its engineers. And so so that's what I will say as my first two slides. And so the next slides, I want to kind of paint a picture on how one can actually make maybe perceive and see what the future is like, and to understand how we as an industry or industrializing powerhouse can make those changes. I usually have my own, everyone has their recipe. I have my 7 steps for increasing intangible assets. Intangible assets are ideas, thoughts, and vision, and how you can actually make things work. This is on the bottom left is a graph from The Economist. And just from maybe a couple of years, maybe a year ago, you can see that in 1975, the market value of intangible assets in the S&P 500, this is the 500 top companies on in the American Stock Exchange, S&P, was in the range of 20%, less than 20% in 1975, and much of them were in the form of some form of patent or goodwill, some trade secret. Goodwill means references, so for example, if you start buying a refrigerator made by Godrej and you think Godrej refrigerators are good, you have built up goodwill, and therefore you buy, and people will buy more Godrej refrigerators. If you have an iPhone, if you think an Apple iPhone is a good piece of mobile phone, then you'll buy more of that. So there's goodwill, there's patent, and there's trade secrets. They are all part of the intangible assets that engineers can build. And so in 1975, it was only 20%. If you look at today, with all of the top Dow companies, whether it's Google or Amazon or Facebook, the intangible assets are now well over 80% of the S&P 500. So, so it's really all about ideas and how you manage those ideas that are going to be key to your success as engineers. And so, so some of the concepts that we need to understand are how to build your portfolio of ideas, and and uh, usually, and I've been through this maybe 30 or 40 times in this past 30 years, this whole process of building intangible assets. Usually you want to first find a limiting problem. In the case of engineering, it's usually some physical aspect limits uh, your solution, so physics, but it could be other things. So find the limiting problem and then try to solve that limiting problem using whatever approach you have in your branch of engineering. But most engineers stop at, I would say, 90% of the engineers stop there. They solve the limiting problem and move on. And that's great. Engineers are good at solving problems. And so, so we stop usually at when we solve that limiting problem. Uh, so if your table shakes, you put a piece of paper on the table to make it shake less, right? But you don't go to the next aspect of developing an idea, which is a discovery process. From the solving of the problem, you develop ideas, and then you generate intangible assets. Intangible assets are key, and I show those a Venn diagram below. So you'd start generating intangible assets, and then from those intangible assets, develop equipment or methods to convert an idea into something more tangible, perhaps. And then you implement the technology or more increasingly business process, um, and then arrive at a full solution. And each of those steps is a chasm. And so you have to be deliberate in your abilities to go from the discovery step all the way to a full solution when you're generating intangible assets. And it usually involves one of these three or all three of these Venn diagrams. You either need to patent. Most people in engineering colleges don't know how to patent. And it is one of the most important tools you'll ever, if you are an innovator, if you believe you're an innovator, it's one of the most important tools that you need in your war chest, um, is to learn how to patent. Uh, and then trade secrets. Trade secrets are important. Increasingly, analytics, smart analytics, AI, machine learning, all of those end up becoming part of trade secrets. And then you have to be a good engineer to generate the goodwill and your references to then infect people with whatever you have developed. I want to shift tracks a little bit. I want to describe innovation in a very different way. And so I want to talk a little bit about innovation lifecycle. And there's a book written by Clayton Christensen of Harvard. It's called The Innovator's Dilemma. And he talks about this whole concept of disruption. And he talks about disruption in the context of digital file storage. And many of you students don't know about some of the earlier forms of file storage, but maybe the professors in the virtual rooms know about it. We started off with the 5.25-inch floppy disk, we used to call them, and then we moved through file storage. No one even uses external hard drive anymore. It's usually some other form of file storage. Cloud is a main aspect now, and so the evolution of digital file storage, and every step was a disruption. And Clayton Christensen called it, it was like fruit flies. Changing every few years, it was disrupting itself into a new form, and he called it fruit flies. So I started scratching my head a little bit and said, if digital file storage is fruit flies, there must be all kinds of other animals around. So I started thinking of scales of innovation. If a fruit fly only can live for a day or so, a few days anyways, like for example, the housefly on top, an elephant can live for 70 years. So innovation must also have different life cycles and different gestation periods. And so these are, for example, the gestation period. A baby rat takes 21 days to gestate into a mature adult, while an elephant could take much longer, more than 2 years, for example. So the gestation period is quite different for different innovations, and so also the obsolescence rates are different. And so I divided the family of innovations into three animals. I call them the hare, the horse, and the elephant. Um, and you have all kinds of different types of innovations that have different innovation cycles and different scales. Um, a lot of innovations that are made to last for a long time, concrete structures, are elephants. They don't go obsolete fast, but they are innovations nonetheless. So there are innovations that go through a long gestation period, sometimes greater than 5 years, and then they last for over 100 years. And then a lot of the mechanical equipment, they are horses. They last for about 20 years before they go obsolete, and so they have different lifespans. And then more recently, what we'd call in the smart technologies in the newer branches of engineering, um, are, for example, sensors and different smart equipment that have shorter gestation periods. Perhaps they have gestation periods of less than a year, much less than a year, but they may last only for 5 years. So their obsolescence rates are much faster, and for engineers to recognize that and to develop their business philosophies around gestation periods and obsolescence rates, it becomes important. Um, in a lot of cases, these hares, horses, and elephants are all integrated into one technology. So, for example, you could have in this picture is in the water sector, we have a concept called an anaerobic digestion process, and within the anaerobic digestion process, you may have a mixer. This is one of those, the way they call it, hyperclassic mixers, and then you may have sensors. And so how do you actually work within the context of different scales of innovation within the same device? Aircraft, the Boeings and the space shuttles, certainly they were elephants in terms of their gestation periods and the amount of, the Boeing 747 lasted for a long time, 50 years perhaps. But the smart systems in the Boeing and the equipment had different gestation periods. And so as you think of innovation, you really do need to understand the scales of innovation, but they're all innovations nevertheless. The other aspect that becomes important in innovation, especially when you're innovating in the context of long life cycles, is horizontal versus vertical innovations. Often innovation is verticalized and technology is verticalized. I'll give you an example. In most of India, water utilities will verticalize their infrastructure into a 15-year net present value, NPV, they call it. And so this is engineers do that. They verticalize it into a 15-year NPV. However, concrete infrastructure lasts for well over 100 years. So how does a 15-year NPV work in the context of a concrete infrastructure that lasts 100 years, while mechanical equipment in that same infrastructure lasts for 20 and the sensors last for 5? And concrete infrastructure, for example, is is somewhere in the range of 50% to maybe 2/3 of the infrastructure cost, but but will last for 100 years, but is given an imaginary shorter lifespan of 15 years in an NPV assessment. And so it artificially increases the value of the capital infrastructure and decreases the value of the operating and maintenance infrastructure associated with a lot of what we do. And so and those artifacts result in building the wrong infrastructure. And so and this is not in the tens of millions, this is not in the hundreds of millions of dollars or rupees, but in the trillions of dollars that we create artifacts by 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 creating verticals associated with how we build and how we innovate today in terms of infrastructure, technology, and so on. On the other hand, sometimes we invest in analytics and devices, so the hairs of our professions, as though they are elephants. So we don't think of their obsolescence cycles and imagine that their life is 15 years, while they're or 15 or 20 years, while their life may actually be only 5 years, and they go obsolete much faster. And so we mischaracterize the obsolescence rate of the hairs. We completely mischaracterize the obsolescence rates of elephants. So this is how we really
Sir,
I think he has got disconnected, ma. Network issue நினைக்கிறேன்.
okay.
வெயிட் பண்ணுவோமா?
Yes, ma'am, we shall wait. Participants, please
அது அவர்
wait.
ஸ்க்ரீன் ஷேர் ஆயிருக்கு. அவரோட கேமரா தான் ஏதோ இதுவாக இருக்குல்ல, அப்படியே ஹேங் ஆன மாதிரி இருக்கு.
So our upcoming webinar is on tomorrow, 3rd June 2020, and it is on Are You Master of Your Androidness? It is from 4 p.m. to 5 p.m. and it is being conducted by Mr. Hari Kishan, release train engineer, Verizon Data Service Limited. Participants, please be connected until our chief guest
My sir is waiting, ma. You can kindly admit. Elizabeth, check it out. Hello, Elizabeth, can you hear me?
Yes, ma'am.
Yeah, sir is saying he is in the waiting room. Is it so?
No, ma'am.
No.
Ma'am,
Okay,
you can join.
He can join
We have,
directly, ma'am.
yes, ma'am.
okay, I will ask him to rejoin.
Once he joins, I'll make him as co-host so that he
Okay.
can start his screen share.
Okay, ma. Okay.
Yes, ma'am, sir has joined. Sir, are you there?
Okay.
Yes,
Yeah.
he has been made as
Yes, sir. Sir, can you please share your screen?
Yeah, I'll do that.
And
Can you see it?
yes, sir. Can you switch on the video?
Okay.
Yes, sir. Perfect.
All right. I don't know what happened there. I got disconnected. So when we look at horizontal versus vertical, one needs to start thinking through and building a scales of innovation associated with how you build things and how you actually industrialize yourself. Um, one thing that's really changing in more recent times is what I would call them platforms, um, and really what's ended up happening in these past decade or so is that the smart infrastructure has helped us develop new forms of business processes. And these business processes help us change how we practice our engineering. Uh, I can give you an easy business process that most people know that has completely changed what we do. Um, uh, for example, ride sharing. Ride sharing means the Olas and the Ubers have completely changed how we uh, get a taxi or how we get a hotel room. So these are new business processes that 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 look at different approaches to 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 bring new ways of doing things. And these business processes typically use some form of sensors and data driven analytics, and then they change how the aggregation and franchising is done. So instead of it being a taxi from a taxi company, maybe a government taxi company, the aggregation is done differently, using maybe private cars and private individuals uh, that are aggregated and franchised in different ways to build new structures and new business processes. Incentives, they're more driven by incentives than being punitive. A lot of some of the old business structures tend to have punitive approaches to managing relationships, while these new business processes use incentives to drive new business processes. So, for example, the stars that you give the ride-sharing cab, whether it's 4 stars or 5 stars, creates incentives and behavioral approaches, new forms of behavioral approaches that transform how we work within the context of society, meaning the incentives and behavior, how we aggregate and franchise, and how we use um, our hairs, our sensors and data-driven analytics to build new engineering processes. So we have the same scales of innovation, the horizontals, but we have new and different business processes that are being developed that help us do things differently. What I wanted to do was give you just some examples in the field of water on how these business processes are different. But I can tell you there are probably thousands of business processes that are still to be discovered in engineering that will drive future innovation. And so you can only imagine 20 years from now how different our world will be relative to today. And it's really being driven by this intersection of engineering and business processes. I'll give you an example of a water utility. It could be an electrical utility, power utility. It could be a telecommunication utility. It could be a transportation utility. But utilities are changing. In the old days, how we managed our warehousing, our assets are completely different compared to how we source and replenish and automate and understand how things are done. Prognostics have become much more important in terms of what we do and how we predict things. And we are creating all kinds of new platforms around around the industrial platforms of utilities, but also in manufacturing. And so there's a massive new change occurring right now. It's already occurred in many sectors, but fundamentally we're changing how we work as industries, whether it's in water or other fields of engineering. And so these are going to be key to the future, are these different business processes that drive engineering. Another example, I'm going to show 4 examples, very, very different, but all in the context of water. This is a utility business platform. How we interact with our customers in terms of billing and meter reading and reference models, tracking hours, payments, databases for transactions are completely changing in the context of a utility business platform. And in the future, concepts like blockchain might become more important, where transparency and traceability of what you have done becomes important. And so as we move towards a much more transparent and traceable interface of platforms, how we actually transact becomes important, and that openness will drive efficiency and resilience. A utility consumer platform is really perhaps how we interact at with the customer base. I'll give you 2 examples. From a resilience perspective, how we manage rain barrels and cistern, they can all be automated using sensors. To manage floods in a city. A lot of big cities are now looking at green infrastructure to manage floods. And so how do we actually manage that using rain barrels? While in dry years, in times of drought, the same rain barrels can store water, but in times of floods, those rain barrels can prevent flooding of sewers associated with green infrastructure. So that's just one example, but there are many of these examples that are there that can completely change how we interact in a very decentralized and disaggregated way, but then to aggregate. So from this disaggregation approach, we then aggregate that information in different ways to create a platform. And then you could have these practice community platforms. There could be digital watersheds, for example. Why we verticalized in our sectors rather than integrated in terms of the watershed itself. How would Chennai deal with water through aggregation of its watershed rather than have it all disaggregated? And so we need to rethink what our watershed is and how we work within the context of this platform. The figure below shows the early greening of lawns from septic tanks, and to using satellite imagery to know where septic tanks are failing and where septic tanks are working, for example. And so you can use sensors and data to know and understand what's working and what's not working through aggregation of information that's decentralized. You can also simulate impacts, storms, and other events. There was a cyclone in India a couple of weeks ago. There's another cyclone coming in this week. How do we actually work and understand and manage resilience while also restoring pollution, all at the same time in these watershed-based platforms? So it's going to completely change how we interact with our environment over the next decade or so. And so those are going to be key, at least in the context of my branch of engineering, environmental engineering. But imagine other branches of engineering, how things will completely change. And it's all based on these new business platforms that can aggregate information differently. Um, uh, there's a lot of talk about smart cities and IoT, and utilities are really a key factor in the IoT platforms, Internet of Things platform of smart cities, and how all of the different utility sectors interact with each other to create a smart city. And so these are practice community type platforms. So I just gave you four ideas, but there are probably 1,000. But they're going to completely transform how we do things. Last, I wanted to talk about partnering. Historically, partnering has been in silos. Sometimes universities do research, and they create their university silos. Then manufacturing has its own silos. And then the utilities, who are usually adopters of new technologies, they have their own silos, and then there are best practices that are usually sometimes regulated that actually prevent the obsolescence of technologies. So a best practice is the converse of obsolescence, meaning it's such a good practice that you don't want it to go obsolete, even though it may demand to go obsolete sometimes. So we create these silos in our supply demand approach of innovation. What I see happening because of new business processes is a much more of a partnering, open innovation model. That's what I've really been leading up for the past 15 to 20 years, is developing open innovation business models where the universities or the researchers and manufacturing and utilities and best practices are all intermeshed rather than in their own silos. And it changes who you're loyal to. Are you loyal to your university, or are you loyal to the innovation itself? And so you manage loyalties in different ways to create open innovation models. I've been involved in many open innovation approaches, and they don't have to be within the context of North America. Sometimes my open innovation approaches have been a discovery in North America, while the demonstration may be in Europe, and the commercialization could be also open innovation in Asia. So you can have different forms of open innovation at different levels, whether it's in discovery, demonstration, or in commercialization. So I will end my presentation by saying that in the next 20 years, there's going to be huge changes in India. There are new ways of doing business, new innovations. Engineers are going to be at the center of it. So you as engineering students will really be key to transforming what we are today and how we do business, how we interact with society, and how we increase world GDP. So with that, I can take some questions.
Yes, sir. Thank you, sir. We'll go ahead and take some time for questions now. Just a reminder, participants, please be sure to type your questions into the chat box. Um, it looked like we have few questions. Um, is innovation in engineering is really helpful or it is doing bad?
I don't know if that's a philosophical question. Um, I think the concept of engineering, within the term engineering, there is innovation in there in itself, right? So in innovation is really about implementing new ideas uh, that benefit society. And so if it doesn't benefit society, it's not innovative. So I would almost say the term itself belies its desire to benefit society.
Okay, sir. Thank you. And the next question. Hi, sir. Variety of sensors are used in many innovations, and then it is play a major role in innovation or not.
I didn't understand. Yeah, absolutely. Sensors are transforming how we interact in society. Um, a lot of how we did things in the past were very centralized. I give you an example of taxi. That was a very centralized process, and sensors allow us to disaggregate and then reaggregate in different ways, and so the ability to disaggregate and then reaggregate is really completely changing how we see ourselves as a society in every every aspect of what we do things. In fact, this virtual Zoom meeting is disaggregation of the university and reaggregating in different ways. So I think sensors are going to be play that key role, and they are going to, and sensors, data, and analytics, all those combined are going to change every branch of engineering and how we in society live.
Thank you, sir. Thank you for the answer. And one last question. Innovations in engineering are amazing, but at the same time, we say the technologies are disruptive. This seems contradicting. How can we justify that we are moving ahead towards engineering?
Yeah, the term disruptive would seem to imply that it's um, it causes harm, right? So by disrupting the old, you're certainly creating chaos in the old order, while you're building a new order. But often when you build a new order, it's better, it's cheaper, and it's sometimes more sustainable than the old order. So the concept of disruption really is about um, change and understanding uh, what was old may needed to have been may needed to have gone obsolete, while what's new is better and better for society as a whole. So I think it's with I would say within the order of some of India's religions, you have to destroy to create, right? And so if you look at the cycle of life, there is the destruction to actually create new things. So it's not very different from the Indian ethos of how we do things. So disruption is as part of that Indian ethos.
Thank you, sir. And one more question just now received. How much goodwill, patent and trade secret is more essential in innovative world? How can we implement those?
So I would say they are important at different points in time. It's not that they're all important in the same percentages, but they could be important in different percentages at different points in time. Goodwill becomes more important usually in the latter part of an innovation, when after the adoption has occurred and people like that innovation, and so then that's when goodwill becomes much more important. In the early part of innovation, sometimes the patent and trade secrets are more important. You have to decide whether to do a disclosure, which is a patent, or a non-disclosure, where you don't want to disclose your idea, and that becomes a trade secret. My main barometer for a disclosure versus a trade secret is if something is fundamental to making things work, might as well make it a disclosure, so that you say that it's your idea and it's your patent. And if there are things that can be easily replicated without uh, and not very difficult to patent. So if there are things that are very difficult to patent and are easily replicated, then you may want to keep it as a trade secret. But in general, uh, building a suite of intangible assets are really key to um, getting you to become incentivizing the whole business process associated with that technology or system or method that you've created.
Thank you, sir. That was very clear. And one more question. Could, uh, could you explain more about what is digital watershed that you mentioned in your presentation?
Yeah, so there are lots of words that are used about digital watersheds, but let's take, for example, maybe a polluted lake in India. A digital watershed is all about understanding why is the lake polluted, what are the source of pollution, understand and using sensors and maybe even satellite imagery to identify and understand the pollution and manage that pollution and to clean up that watershed. Um, um, and it could be a lake, it could be a river, it could be a groundwater system. So that's a watershed, different watershed, but it's a ground watershed. So how do you manage the quantity or the quality of water within that watershed, and using sensors? And so, for example, if in Chennai the groundwater table is going down or seawater is coming into the groundwater table, how do you actually manage that watershed in a sustainable way for the future?
Thank you, sir. It looks like we have covered all our questions. Sir, is there anything else you would like to share?
Well, thank you for inviting me. I hope what I said was of interest to the audience. I try to make it very general, and so hopefully it was of useful to every branch of engineering that's out there. Um, Also, I have to say that I grew up in India. I was born in India. I was born in Bangalore, and I grew up most of my life in Bombay, Mumbai. I speak Tamil, so Tamil is my native tongue. But it's been a pleasure for me to come back and interact in India. I've been gone for 30 years, and so it's been a pleasure for me to participate in this seminar. Thank you.
That's great. That is great, sir. Thank you, sir, for this wonderful session. And thank you, Shripriya ma'am and Jayalakshmi ma'am, for coordinating this webinar.
Okay. Thank you, ma. Thank you. I want to say a few words to sir. Okay.
Yes,
Thank
ma'am.
you. Thank you very much, sir, for accepting our invitation and joining us in this webinar session on innovation in engineering. Within a short span, we were able to contact you and we were able to freely move with you and communicate with you to getting all your details. Thank you very much once again. And it was a wonderful presentation, sir. Hope students will get benefited out of it. Thank you very, very much. Thank you, sir.
You're welcome. Bye.
Thank you, sir. We thank all the participants for joining us today. Hope you would have enjoyed the session. I would like to share that a great event will never end, and so keep waiting for our upcoming webinar on Are You Master of Your Adroitness by Mr. Hari Kishan, Release Train Engineer, Verizon Data Service Limited. Participants, please register and get benefited. Link for feedback form will be posted in the chat box and your YouTube channel. Participants, please fill the feedback form correctly and get your e-certificates. I repeat, participants, please fill the feedback form correctly and you will get the e-certificates. Thank you all for your participation. Stay safe.